everyone. Well, it's a very interesting time. I'm currently teaching this to a 6-year-old because nobody else is in the room. So we are starting a new topic today, which is Bivariate Data Analysis. Okay, so lots of graphs, lots of being able to read graphs, draw graphs, and interpreting graphs, but probably graphs you haven't really gone into too much detail about just yet. So we are going to start with constructing a bivariate scatter plot. Okay, so bivariate data is data that has two variables. Okay, makes sense. Bi means two. A scatter plot is used to determine if there is a relationship between two numerical variables. So data is collected on the two variables and often displayed in a table of ordered pairs. Okay, so your ordered pairs is just your XY, your XY table. That will give you your ordered pairs. Each ordered pair will represent a dot on the graph. So to illustrate this process, a scatter plot has been constructed to determine the relationship between the height and arm span. The data collected on these variables is shown below in the table of ordered pairs. So here we've got height in centimetres is above the top. And arm span in centimetres is along the bottom. So each of these, this represents one person. Okay, so one person is 172 centimetres tall and they have an arm span of 172 centimetres. Okay, so if we were to then put that on a dot, a scatter plot, this is what it would look like. Okay, so your X variable, whatever variable is in the top of your table, is your X variable, which is your independent variable. So that would be our height, and then our arm span is our our dependent variable, which is the Y or the bottom row of our table of values. Okay, so each person has two numerical variables, a height and arm span. So to construct a scatter plot, we need to draw a number plane with the height on the horizontal axis and the arm span on the vertical axis. We're going to plot each ordered pair as a dot. So each of these dots represents a person. Now it's not a line graph, so we're not going to join the dots together. Okay, we're just going to leave it as it is. Alright, so speaking about what bivariate data is, okay, so it's data that represents two variables. Why is it important? We want to look at the relationship between these two variables, so to do that we're going to put it on a scatter plot. So I'm going to now go to your example booklet. So this one here. Now I have uploaded it on to Google Classroom that you can print off and fill it in, or I have left copies for you up at the office if someone is able to go and collect them. It's up to you which way you want to go. Okay, so we're going to look at exercise 6A today, which is constructing a bivariate scatter plot. So you're going to need a ruler. So hopefully you have a ruler somewhere at home or something that would work well with a ruler. So bivariate data is data that has two variables. It can be displayed on a table as ordered pairs and graphed on a scatter plot. Okay, so first thing you need to do is draw up a number plane. Then you need to determine a scale and a title for the horizontal or x-axis. So height is our top row of our table, so that is what's going to go on the x-axis, which is height. Arm span is the bottom row of the table, so that is going to be our dependent variable, which will go on the y-axis. Okay, and obviously we put the units that they're measured in as well. Now, when we normally do graphs, we need to make sure that we actually start at 0, okay? More so the vertical axis than the horizontal axis. Now in this case they haven't. Now what we normally do is if you don't start at 0, or you start at 0 but then you miss quite a few numbers, you need to put that sort of symbol in, okay? Otherwise you can't just start at 150. You're not really meant to, okay? But make sure that your scale is consistent in what the numbers go up to. Make sure that it's consistent in the gaps. Okay? Alright, so let's have a look. Alright, so the table below shows the mass of 10 infants and their mass. So we've got, the height of 10 infants and their weight. Okay, and we're going to see if there's a relationship between the height and the weight of infants, which is just young children. Okay, so we're going to draw a scatter plot to represent this. Now, height is on the top row of the column, so that is going to be on your x-axis or your horizontal axis. Now, it starts at 40 and it goes up to 85. So we can start at 40 and go up to 85 for that. Okay, so height's going to go here, writing the units down. So it starts at 40 and goes up to 85. So 40, 50, 60, Now you can go up by 10, you can go up by 5. As long as you're consistent and it fits, it doesn't really matter. Okay, and then we have got the weight of the infants up on the vertical axis, and that was in kilograms. Okay, so starting at 0. And then we'll have 11 up the top. Okay, so there was an infant who was 40 centimetres long and had a weight of 1.5. So we draw a dot, go across to 40, up to 1.5, draw a dot. Then we've got 45 centimetres long and 3.1 kilograms. 50 centimetres long and 3.6 kilograms. 55 centimetres long, 5.5. 60 centimetres long and 6. 65 centimetres long and 6.9. 70 centimetres long and 7.6. 80 centimetres, 75 centimetres long, no, have I missed one? 65 is 6.9, 70 is 7.6, sorry. 75 is 8.6. 80 is 10, and then 8.5 is 11.2, so they're up there. Okay, so we don't join it with a line, we just leave it as it is. Okay, now looking at that, we can see that there is some sort of relationship between the height and the mass of the infants. It's in a fairly straight line. There is a pattern there, and it's in a fairly straight line, and the line is actually going upwards. Okay, but in exercise 6B, you will go into more detail about being able to describe the relationship between the two variables. But for exercise 6A, you're just going to be drawing the variables and then commenting on whether there is a relationship. So if it was all over the place, then you say no, there's no relationship there. With the conclusion with this, we can see that there is a pattern that as the height increases of the infant, so does the mass. Okay, that would be the conclusion that we would come to. Okay, if you have any questions, then feel free to ask, otherwise that's pretty much it. Exercise 6A, question 1, 2, 3, 5 and 7, and that is for today's work. Alright, good luck with it all. Bye.